All right. So a lot of people needed a lot of help with this question. I'm a little bit confused by that because that is a prism. And the volume of every single prism is area of the base times the height. For some strange reason, even though we have talked to death about what the base is, a great many people in all three classes do not still understand the concept of what a base is. The base is the shape that repeats. You can only see three shapes here. One of those three shapes appears twice on this prism. Is it the yellow rectangle? No, of course not, because the yellow rectangle at the bottom has this angled piece, so it can't be the yellow rectangle. Could it be the blue rectangle? No, of course not, because the blue rectangle over here is much longer. What is the only shape left? The green shape. That is that shape, which, even though I drew it badly on purpose to see what members of my clientele are able to think, you shouldn't have had a problem with it. If this is 1, what's this? 1. So that means, what's this? 1. So what is the area of that rectangle? 1 by 15. So the area of the base is at least 15, but there's some more to it. There's this bottom triangle down here. If this is 1, how long is this little bit? 7. How long is this? 15. That is half a rectangle. 7 by 15 is 105, but you cut it in half to get 52.5. So you will add 52.5 for a total of 67.5 for an area of the base. Then you multiply by the height. We have talked to death about what the height is. Is height up and down? No, because up and down doesn't exist anywhere but when you are standing on the planet Earth. If you are in space, there is no up and down. Up and down is something we have invented. Height is the direction the base repeats. Since you have decided this is the base, rightfully so, it repeats that way. How far? 6. To give a volume of 405 meters cubed. But we are not filling the pool to its entirety. We are only filling it 85% full. So we must do 405 times 85%. Most of you cannot stand fractions, so hopefully you remember the 6th grade when you were taught percentages. 0.85 to get 344.25 meters cubed. Yeah? I have an answer. But first, I'm going to have a scoop of my lunch while you ask.
How did you get 52.5 again?
One, 8. 1, 7. 15. 7 by 15 is 105 if it were the whole rectangle, but it is not. It is half a rectangle, so it is 52.5. Whoop. Now, in question 2, it says 1 liter of water equals 1,000 centimeters cubed. Yes, Karen. Because this part of the shape was 15 by 1, which is 15. The rectangle at top was 15 square meters. The triangle at the bottom was 52.5. No problem. You have meters cubed. What do we need? centimeters cubed, correct? So we must turn meters cubed to centimeters cubed. How do we turn meters to centimeters? Jovan. We multiply by, not 1,000, meters to centimeters. It's 100, correct? Right? So meters to centimeters means we're multiplying by 100, right? But we are doing how many dimensions? 3 dimensions. Must we not convert the length, the width, and the height? So must we not multiply by 100 thrice? Once for the length, once for the width, once for the height. So we had 344.25, but I need to convert the length times 100, then the width times 100, then the depth times 100, to get a total of, how many zeros do you see there? 6. So how many decimal places must this move? 6. What goes in the holes? What number goes in the blank decimal places? Zeros. So I have 3,000,025, 1, 2, 3, 5, 6 zeros. I lie, 4 zeros, because 2 of our spaces are there. Is everybody cool with that? I probably need to stop there because some of you are saying you're cool with that, but you're actually not. Do you all understand how to convert squares and cubes between the different measurements? You all know how to do 1. 1 meter is 100 centimeters. Do you all know why I did it 3 times? Does everyone understand that? If you don't, you need to ask me right now, or you need to come and see me if you do not understand that. It is a very important concept in a great deal of work you will do, or you have the possibility of doing in your life. Is there anybody that needs that explained again? All right. And you know what? I'm going to leave it recording. One meter. Yes, Josh.
The first question, it says how long will it take to complete?
Yeah. Oh, I forgot to do that. I'll fix that up in a sec. 1 meter, yes? How many centimeters is it? 100. Does everybody understand? Great. Now draw a square. 1 meter, agreed? How many meters squared is this? How do you find the square meters of that square? Length times width, which is what? 1 times 1. So this is 1 meter squared. Agreed? Okay. How many centimeters? 100. How many centimeters? 100. How do you find the centimeter squared of this? Length times width. 100 times 100, which is 10,000. 1 meter squared equals 10,000 centimeters squared. Because I had to convert that and that. So if I were showing you all this math, to convert 1 meter to centimeters, I need to go 1 times 100. Agreed? Everybody agrees, right? And then down here, I would need to do 1 times 100, right? Everybody agrees? And then to find the area, I would have to do the length times the width. Everybody agree? Times. Agreed? So now look. What do you know about multiplication? Does order matter? No, is 2 times 5 same as 5 times 2? So, if I change this order, 1, I'll change color. 1 times 1 times 100 times 100. There's my 2 conversions. Everybody understand? Now over here, since I'm doing volume, I had to do a 3rd conversion to cover the 3rd dimension. Everybody cool? Does everybody get it now? Okay. Now, as Josh says, I forgot to finish this off. You had to divide that by 1.8 to get 191.25 hours. Right? Now, we're back to here. We have converted to centimeters cubed, haven't we? Agreed? Now, centimeters cubed, I want liters. I have been told right in the question, right here, that 1 liter equals 1,000 centimeters cubed. I want liters, don't I? So, I multiply the number with which I am working by the fraction of what I want, which is 1 liter, over what I have, 1,000 centimeters cubed. 3 zeros there. What happens to 3 zeros up here? They cancel. And I'm left with 344,250 liters. Everybody good? Now, if you didn't convert this right, you will end up with 34 liters. This is 1 liter. Will 34 of those fill up the MRC's pool? Of course not. So would you hand me in that work that made no sense? No. Would you believe your calculator over your brain? Yes, you all would. Because you will write down what is on your calculator because you refuse to actually think about what is happening. You punch stuff into your calculator and assume your calculator is correct. Do not do that. The real world does not care about your calculator. Okay? Next question. Now, this was worth 10 gummy bears. I will take guesses. Does anybody wish to offer a guess? Only 2 out of 30? Oh, a couple more. 3 out of 30? 10% of the class wishes to offer a guess on something that cannot possibly hurt them, might gain them 10 gummies. Go. Pardon me? 192. 193. 14,900. 14,976. Is that it? Oh, Marcus. 192.7. Nobody else? Tiana. Maddie? Oh, you're her lawyer? Nice. I hope she's paying you. If she gets a gummy bear, she owes you 10%. 19,275. Anybody else? No. Not wait. You have to check it for what reason? Do you think some monster is going to come through the door and throw you around if you are wrong? Okay. This is not Grimm's fairy tales. This is Math 10. There is no ogre coming through the door. Do you swear? Oh, I'm sorry. I did not see you. Go. 19,268. Well, we are all over the map here, aren't we? I will tell you one of those answers is correct. And that answer is... that one. How many people worked on it with you? 2? 5 gummy bears each. Go get them.
Oh, but the other, okay.
He's not here. That's his problem.
Do I take 10?
You take 10 total because that was the prize. If you chose to work with a team.
Yeah, his name's Arsh Ken.
So, ladies and gentlemen, what are we doing to the net? We're filling it up, right? Which means we must care about volume, yes? So, do we all agree? Did everybody do volume? Okay. So how do you explain 192, which you can see we had 3 guesses of, and as high as 19,000? If we all did volume, how is this explicable? I would guess that part of it is this. The net, and I will draw it in red. No, that's no good. The net looks like that. Agreed? Everyone agree? Okay. How wide is the net? Long, wide, it doesn't matter. How long is this line that I am highlighting? 1.83. How long is this line that I am highlighting? 1.22. And how long is this line? 1 meter. Agreed? What are the pucks measured in? Centimeters. How many people found the volume of the net by going 1 times 1 times 1? Because it's a rectangular prism, so isn't it 1.83 times 1.22 times 1? It is, isn't it? And then if you do the volume of the pucks in centimeters, can you compare the two? No, you can't. So that's the mistake a bunch of people in the first classes made. They didn't remember that these are in meters and the pucks are in centimeters. That's a problem. Everybody cool with that? All right. Next problem. What shape is this net that I've drawn? A rectangular prism. Agreed? What shape are hockey pucks? Circles. So I'm going to draw you a rectangle right here. And I'm going to fill it with hockey pucks. What do you notice? Right there, right there, right there, right there, right there, right there. Empty space. Can the pucks fill that empty space? No, because they're circles. So what you actually had to do was recognize that this distance along here was 183 centimeters, wasn't it? And pucks, which I will draw in black, are how wide? 7.62. How do I tell how many 7.62 centimeter pucks will fit across 183 centimeters? Divide by 7.62, which gets me something in the neighborhood of 24 pucks across here. Everyone agree? Excellent. How tall is the net? 122. How tall is a puck? How do I tell how many 2.54 centimeter pucks will fit up and down? Divide by what? To get a total of 48. So now I got 48 pucks going up there. So how many pucks will fill in this? If there's 24 across here and 48 up there, how many pucks will fill the front of the net? 24 by 48, which is 1,152, correct? How many pucks will fit back here? How long is this? 100. How wide's a puck? 7.62. To give you how many pucks will fit back here? 13. So my base is 1152, and I can fit that rectangle 13 times going backwards to get 14,976. Was volume what you needed? Yeah. But you had to use your brain. Because unless you were going to melt the pucks down into liquid rubber and then pour it into the net, you do not need 19,000 because you cannot fill the empty space. Everybody understand? Is this a math class question? Obviously. Are the skills needed to do it a math class skill? No. It requires thinking about how the numbers affect the real world. Where do you people live? The real world. Right? Well, some of you live in Fortnite, but not all of you. Aye. That's a super hard question. That's why it's now. Right? But when you think about it, is it really a super hard question?
No. It's like logical.
Yeah. Right.
I really wouldn't think
No. But the math itself wasn't difficult at all, was it? Understand the difference. All right. Now, where on that can does the paper live? Only on the sides. Is it surface area or volume? Surface area, because the paper's on the outside. Surface area of a cylinder is 2 pi r squared plus 2 pi r h. Which part of that do I not care about? The 2 pi r squared, because that's the top and the bottom. Those are circles. I'm not putting any paper on the top and bottom. So I only care about 2 pi r h, don't I? Everyone agree? Okay. How many cans of... That's one can. How many cans of soup are there? So that has to multiply by 100,000, doesn't it? Right? Everyone agree? So really, I need 200,000 pi RHs, correct? Great. What's R? 4.25. Lovely. What's H? 12. Lovely. 4.25 times 12 is what? Pardon me? 320.44. 4.25 times 12. Oh, you multiply by pi as well. Right. Okay. Don't do that, and you'll see why in a minute. What is it? 51 times 200,000 is what? What? 51 times 200,000, guys. What's 51 times 2? 102. Plus how many zeros? Plus how many zeros? Because it's 51 times 200,000. So it's 51 times 2, which is 102, with how many zeros? 5. Pi. Everyone agree? And what is that being measured in? Centimeters cubed. Is everybody okay with what I did there? Why did I not put the pi in? Because I don't want some crazy number, because I'm not done with it yet. I'm going to be doing more work. So do I want a crap ton of decimals yet? No. So there is how much paper I have, agreed? Measured in centimeters cubed, yes? If we were going to put covering on the walls of our classroom, would we measure the walls in centimeters? No. Oh, it's not cubed, it's squared. Sorry, guys. It's squared, of course, because it's area. Sorry. We would not measure it in centimeters, would we? Because that would be stupid, wouldn't it? What would we measure the walls in? Meters. Now, our classroom, this is particularly difficult. Why? Because I got the triangle, right? But I did say estimate. So can we just go ahead and assume all the walls are flat? Is that fair to do in an estimating situation? Okay. So this wall right here has a big tall side, down to a shorter side, down there. Agreed? Everyone agree that's what that wall looks like? How many of them are there? 2. There's that one and this one, yes? So whatever this area is, I must multiply by 2 to get it, correct? Then there's the small rectangle that would be right here where the windows are, yeah? up to the triangle, over and down. Everybody cool? And how many of them are there? One. Then there's the big rectangle that would be over here. Is everybody cool with that? How many of them are there? One, just that wall, yes? So now we have to estimate a measurement. And Nicholas says we should measure in meters, yes? I didn't notice anybody get up and grab a trundle wheel or a tape measure because there aren't any here, are there? But we spent a good long time on the very first day talking about reference, didn't we? Didn't we? And didn't we all agree that a good referent for a meter was a step? We did, didn't we? So if I walked across the room, would I know how big it was? I'd have a good estimate, wouldn't I? Anybody want to walk across the room because my knee hurts? Or does everybody want to be lazy? Thanks, Derek.
Let's go, Derek. Start over there.
Yep, you know it, brother.
How would you measure?
It's like big steps. Or like normal.
We'll talk about that in a minute. A decent-sized step. A good stride.
2, 4, 5, 6, 7, 8, 9. Let's call it 10 because it's easier to multiply. Are we happy with that? Okay, so we know across the bottom is 10. Agreed? Are we going to assume the room is square? Yes.
We're only estimating. Can we assume the room is square? Okay, so that would make this 10 and that would make this 10. Agreed? Does everyone agree? Now, you see what approximately 10 meters looks like, yes? You have eyes, yes? Okay, how tall is it up to there? No, to the little one. You want to call it 8? Are we happy with 8? I have no problem with that. Okay, so this must be 8 up to the short side, yes? Which makes this what? 8. What does that make the long side? If 8 goes up to the bottom of the triangle, what's left up top? Another 8, you want to call it?
No.
I don't think so. 6? Okay, so that makes this whole side 14. But this is a pain in the butt shape, isn't it? Except we've already dealt with it in this set of exercises, haven't we? Because that is just this rectangle. 8, and you said that was 6. So how big is this? 80. How big is this? 6 by 10 is what? Divided by 2? 30. So how big is this whole wall? 110 times 2? 220. Is everybody cool? How big is this guy? 80. So I got to add 80. How big is this guy? 140. So I got to add 140. Is everybody cool? So now I have 440 meters squared. Yes? Everyone agree? Everyone agrees? Okay. I have that many centimeters squared. If I want to convert centimeters to meters, what do I do? No, centimeters to meters. Divide by 100, right? So I want meters, right? So meters goes over centimeters. 1 over 100, correct? But I'm doing 2 dimensions, aren't I? So what do I got to do? I got to do it twice. So I got to divide this by 100 and by 100. So isn't that the same as dividing that by 10,000? Isn't it? Okay. 4 zeros. What do I get to do with 4 zeros up here? What do I get to do? Cancel them. Right? So I have 1,020 pi meters squared, don't I? And I have 440 meters squared to cover. What do I do with those two numbers? Divide, right? because I have this much space and I got to see how many chunks I can fit into it. So I divide that by 1020 pi. Well, 1020 pi is going to be around 3,000, isn't it? Isn't it? 400 divided by 3,000, that's only like 1/6, isn't it? So I could only cover a very tiny bit of my classroom walls with those labels. Everybody cool? Good. Let us move on. Again, what's more important with that question? Understanding that centimeters, meter, all that stuff, right? And using reference, right? Now, Nicholas asked, how do you do the height? By guessing, right? This is about 10 meters, so that's about 10 meters, or whatever. Okay. We're on our wheel, on our bike. What measurement of this wheel will tell me how far it travels? Well, the question is, how far will I travel if I turn the wheel once? Well, here's the wheel starting on the ground. How far, what measurement of the wheel will show me how far I went? Circumference, all the way around, right? Because if that wheel rolls around, when it gets back to there and I stop, I've gone once, yeah? So I must need the circumference. Is that available to you? Yes, it's on your data booklet. Circumference equals pi d, right? What's the d of the big wheel? So the circumference equals 52 pi inches. Everyone agree? My first one, I want my answer in feet and inches. So how do I turn this into a number I can work with? What do I do with 52 pi? Can I go to Home Depot and say I need 52 pi lengths of rope, please? What do I do? Multiply pi by 52, and I get what? 163.36 blah inches, correct? But I want feet and inches. So how do I turn that 163.36 inches into feet, which is what I want? 1/12 inches, right? That's divide by 12, yes? And that gets me 13.61. Which part of that is the feet that I care about? The 13. But I'm left with 0.61 of a foot, yes? I need that in inches. I want inches. I have feet. 12/1. 0.61 times 12 gets me 7 inches. Does everybody understand that? I can tell from all the writing down of things now, it's a good thing that today was still not the first day I did a homework check. Now I need this in meters and centimeters. I know I had 163.36 inches, correct? If I go to centimeters, it's easy to turn to meters, right? I just got to move the decimal twice. So how do I turn that to the centimeters that I want when I have inches? Right. The 2.54 is up there. The 1 is there. And I get 414.963 or something. Isn't that 415 centimeters? And to make that in meters, how far does that decimal place have to go? 4.15. 4 meters, 15 centimeters. Now, how many times do I got to turn that wheel to go a kilometer? What's this measurement in? Meters. What's this measurement in? Can I compare the two? Yes, but I got to do something first. I got to make this meters, yes? So it is 1,000. Then what math is happening to that? Divided by 4.15. And what do I get? 240. 0.96. So I got to go at least 241 turns, don't I? 241 turns. Now, what about this one? The small wheel. It's trouble, right? So let's think about this. Let's write it down without even going to our calculator and see what happens. We know the small wheel is 18 pi inches, don't we? We need centimeters, yeah? So I got to multiply 18 pi by 2.54, correct? And then, to go centimeters to meters, I got to divide that answer by what? By 100. Everybody cool? And then that answer is going to give me meters, isn't it? And I have 1,000 meters. So what has to go here? This answer. Now I'm going to give you guys a gift on your calculator that I've given you before. How do I punch this in when I have a divided by and there's an operation up top? What do I need to remember to use? Brackets. Bracket, bracket. So, observe. On. Turn on. I said turn on. Turn on. There we go. Bracket. Now, some of you need to push times pi. Some of you don't. But you always can. 18 times pi times 2.54, close brackets, divided by 100 equals 1.436336161. Do I want to write all that out? No. But I am going to write out 1.44 just in case. My calculator has given me that answer, yes? I know I need to do 1,000 divided by that. To get the best possible answer, I should use as many decimals as possible, right? But I don't want to punch in 73 decimals. So here's what I do. 1,000, and I've shown you this before, divided by 99% of your calculators are going to have this ANS key there. For me, since it's blue, I have to push the blue button. I hit second, I hit answer. And my calculator gives me, because it holds it in its memory, the last thing I pushed equals for. So it's sitting right there, isn't it? That was the last thing I pushed equals for. The calculator knows it. 1,000 divided by that equals 696.21. Which means I need to actually turn the wheel how many times? You would round that off to 696, but if I only turn it 696 times, have I gone the kilometer? No. I need to turn it the 697th time. Now, Javon, what?
I was going to ask a question about the quiz.
That would be a waste of time, since we are not talking about the quiz right now. We are talking about this. Any questions left over from this? Now, once again, I will remind you, have we done anything strange? Or have we only done add, subtract, multiply, and divide? We've only done those four. Have we dealt with any crazy shapes like a nonagon or a dodecahedron? Or have we dealt with rectangles, triangles, and circles? Rectangles, triangles, circles. What's the difficulty? Putting it all together. Just like when you go out and live in the real world. You have to put it all together in everything you do in your life. Life is not a bag of Doritos and a Slurpee when you leave here. Okay? All right. Now, would anybody like to ask about their quiz? Javon?
Yeah. What if we do like super, like, what if most of the class like does like bad at this quiz?
Then I'll know most of the class didn't do their homework and practice.
I was going to ask if we would like go over this subject more.
When can I do that? You will notice there are 8 units. There are 4 months, which means 2 units a month, correct? Right? What month is just about to end? How many units have we done?
0.
Can I go over it? Or can I expect you to understand length times width? Probably the second one, right? How do you get good at it? Practice. Why haven't I done any homework checks? How many people did I see writing all that down? A whole bunch. How many people attempted it? Did some people attempt it and they're just correcting it? Yes. Did most people not bother to attempt it? I've been teaching for 20 years. What do you think I know the answer to that question is? How many blank sheets would I have seen if I'd walked around this room? You don't need to guess, because I know. Okay? So will I review? I don't have time. Can you review? Is the entirety of human knowledge available to you on the internet?
Well,
Entirety of human knowledge is available to you on the internet. Stop Snapchatting your popcorn at the movie theater and use your time wisely. Maybe you don't, but I'm guaranteeing you do not use all your time that you could use to get better. All right. Your quiz. For some strange reason, you people seem to think it makes a difference how many questions are on the quiz, because you're going to, I guess, not do them if there's more than you want to do or something. So I'm going to tell you the quiz has 1, 2, 3, 4, 5 questions for which you must do 7 calculations. I know, right? Now, if you know what you're doing and you get 3 minutes a calculation, that's 21 minutes, correct? Everyone agree? But one of those calculations is one number times one number. Do you really need 3 minutes for that? I do. Yeah, go. I will give you 18 minutes from when I hand the quiz out. But I will give you 3 minutes right now to look through your notes, through your books, talk to your neighbor, talk to me. So you are getting 21 minutes of time to be spent on the quiz. If you finish the quiz, please listen to me. You have to have pages 42 to, I want to say 47, but I think it might only be 45. 46 done, inclusive by, you guys are block B, A, by, you're right before lunch, by 10:45 a.m. tomorrow, when we will go over it all. That gives you the rest of this period, all night tonight, to do that few questions. Now, what if you get to a question you can't do? Do you stop? Of course not. You skip it and you go on. Will there be some questions that you think you don't know how to do? Yes. So what should you do? Look at it a bit, then go on. Let me give you an example. If I gave you a 15-question final exam and you couldn't do the very first question, would you spend 3 hours looking at it? No, because that would mean your whole test was blank. What would I give you? 0 out of 15. What if the next 14 questions were 7 plus 3, 8 minus 4? And you stopped at the first one because you couldn't do it. If you skipped it and did the next 14, what would you get on that test? 14 out of 15. Which is a better mark? Right. Which one is better for real life? Do you stop and give up at the first thing that causes you trouble? No. You either do everything else you can and come back to that later, or you actually learn how to power through it. Your choice. Just like when you leave here. It will be your choice. Everybody good? Sweet. Your 3 minutes to figure out what is happening with your test starts now.